Okay, so we have our dial bore gauge all set up, dialed into 4 inches exactly, and we're going to start measuring our cylinder. But there's one problem with our cylinder. There's still a piston in there. We need to get that out of there. All right, so there we go. The piston is now out of here. So we can measure all the way down to the bottom. Now when we talk about measurements, we got to talk about 2 different measurements. And those 2 measurements are taper and out of round. Let's go to the board real quick and take a look at those. All right, so the 2 things we want to talk about when we talk about cylinders not being perfectly cylindrical all the way down is out of round, OOR, and taper. Okay, when we make our measurements, when we have our dial bore gauge or we have our T-handle, what we want to do is we want to measure in 6 different places in the cylinder. Okay, what I like to do is I like to do one set of measurements down one side of the cylinder, turn that measurement device 90 degrees, and then do the next set. So you get the first one going across this way. Okay, the second one going across this way, and then the third one going across this way, writing down all those measurements as we go. And then the fourth one going this direction, okay, and then go down about halfway, go that direction, and then go down to the bottom, okay? So we're gonna measure at 3 different spots, basically, in our cylinder. So it's basically going to give us a little snapshot of each part of those cylinder, okay? When you do this, you wanna do it at the top, middle, and bottom of your piston travel, okay? So as your piston's traveling up and down in here inside this cylinder, if it's only going yay far, then you only want to measure to the bottom of those rings, because what we're looking for is where have those rings worn into the cylinder, because that's what's going to cause your tapering out around, is your rings moving around, or our piston slap around. We talked about piston slap yesterday. If we got our piston sitting in here slapping from side to side, it could cause some wear at the bottom of the cylinder and the top of the cylinder, okay? And one of those wear patterns that we talk about is taper, okay? And taper, a lot of times we're gonna have where we look at our measurements, and when we compare the top to the bottom measurements from one side to the other, say we look at 1, 2, and 3, we might see that number 1 is at 3.995, number 2 is at 3.992, and the bottom is at 3.987, okay? Meaning that we start pretty wide, and then in the bottom we come a little bit more together, okay? It's got a little bit skinnier of a measurement there versus a wider measurement up at the top, okay? Meaning that we've got more wear at the top, because when it wears, the cylinder goes out, okay? More wear at the top than we do at the bottom of the cylinder, okay? And that would be a taper much like this, okay? Where we have it wider at the top and skinnier at the bottom. A lot of that has to do with the piston rings. The place that they have the most pressure on them is at the top, because we learned yesterday that those piston rings, they seal by the combustion pressures pushing down on them, okay? Those combustion gases push those rings out and seal them against the cylinder. Well, where are the highest combustion pressures? At the top of the cylinder. So you tend to see a little bit more wear, and usually you'll see in a worn engine, you'll actually see a little bit of a taper. And you'll want to look at the specifications for that engine to see what the taper tolerances are, as well as the bore tolerances, how wide the cylinder can be. And what we'll do is, if the taper is too wide for a standard piston, then we can do what we call overbore, and we can overbore that cylinder, make that cylinder itself a little bit wider, and then get a slightly wider piston to put in there as well. Some other taper that you might see, more of a piston slap type taper, you'll see it where it's worn really wide at the top and really wide at the bottom. Okay, so that would be like going back to our other measurements and having 3.995, having that 3.992, and then measuring again and having that 3.995 at the bottom again. That would indicate that it has kind of a taper to where the middle is less worn than the bottom and the top. And a lot of times that's because the piston's coming up here and doing a slap. Okay, it's slapping at the top top and is slapping at the bottom, okay? And as it does that, it can sit there and it can wear the taper at the top and the bottom, but leave the middle where it's kind of moving the same amount a little bit thinner, okay? The other thing that can happen too is because when it changes directions, if your rings are worn, the places that it changes directions are at the top and then at the bottom, which means at the top and the bottom of the travel where the rings are sitting, that's where the metal's getting passed by the most. That's where the most change of motion is happening, and that can lead to some taper wear there. Okay, the other thing that we can have happen is out of round. Okay, out of round would be measuring that 3.95 at the top, 3.995, and then turning around and say we measure this and it's at 3.980. Okay. Now I've done an exaggerated out of round here. We have 4 inches here and 2 inches there. Basically what we're saying is our circle isn't a circle. Now it's more oblong. Okay, and so we compare those measurements, and that's why we do the second measurement 90 degrees off, is to check for that out of round. So you'd want to check it all the way down. If it was 3.980 all the way down, even given these measurements, we're still out of round all the way down, okay? And you usually want to see that within a couple thousandths. You want to see these measurements within a couple thousandths of each other. So if this one was like 3.996, and then this one was 3.994, and then this one was 3.994 again, okay? Little bit of a taper, wouldn't worry too much about that. A couple thou. If this was a used engine, if it was a brand new from the machine shop, you might want to take it back because this should be pretty close to dead on. But comparing those measurements, that's your big thing, is you want to look at those side to side. You shouldn't see too much of a difference between one direction versus 90 degrees from that. So I hope that helps to explain. I hope that helps explain tapering out of round for you. Let's go back to our engine and do our measurements. Okay, so I've got my dial bore gauge set. I actually took this back over to the micrometer to kind of recenter this. So now I have the 0 at the top just for easeability. Hopefully you guys can see that in the video. So that when it's pointing directly at that 0, I can't really do it with my hand, there you go. When it's pointing directly at that 0, now that is the 4-inch mark again. So I've recalibrated to the top so that hopefully you can see this. So we're going to go ahead and do those measurements just like I said. And how we do this is we're going to put this in at an angle, okay, so that we can put it towards the bottom. Now, the place that we're going to be measuring, of course, is going to be the spot that has this anvil on it, okay? So we want to go ahead and do straight up and down compared to the block. So stick it in, put it a tilt, and I'm going to measure towards the top of the bore. And all I'm going to do is I'm going to tilt that back. And as I do, you see that gauge go up and then come back down, go up and come back down. And when I look at the gauge, it's stopping about right there. And I'll pull it out and show you. Okay, so at the top, it's actually coming and it's stopping about right there is where it's stopping. Okay, right at about the 3 thousandths mark. Which, remember, each of these small lines in here, that's 5 ten-thousandths, which means that the next biggest line over is 1,000th. Okay, 15 ten-thousandths, 20 ten-thousandths, right, or 2 thousandths. Okay, so when we look at this, 0 and then 5 would be 5 thousandths, right? Because it'd be a half, 1, a half, 2, a half, 3, a half, 4, a half, 5 thousandths. So when we look at in here and we stick this back in here and we make that measurement, and it's coming up right to about the 3 thousandths mark. Let me see if I can get over here and see this for you. Okay, right about to that 3 thousandths mark. Okay, so we have our, right, if it's at 3 thousandths, that means that since we set this up for 0, so the 0 here would be 4 inches, okay? As I push the anvil in, meaning we have smaller than 4 inches when we go to the right, which means when I let the anvil out and we go to the left, that means it's bigger than 4 inches. Okay, so if we were at 0, which is 4 inches, and it's not coming up any higher than 3 thousandths before 0, that means we're wider than 4 inches. So it's actually 4 inches and 3 thousandths, so 4.003 inches. Okay, so we're going to go ahead and measure. We're going to write that down. Okay, and then we're going to go down to the middle of the piston travel. Okay, and when we look inside of this, I'm going to go ahead and pull this up, and I'm going to zoom in. All right, now I got some light on it, so you can see down inside of here, and you can see where the piston was traveling. I had this kind of greased up a little bit, so you do see a little bit of assembly lube down there. That's that red, but you see the difference in the metal. Okay, now one thing I forgot to mention is see how it's not worn at the very top there. Okay, that's where the rings don't ride. Okay. Ooh, Blair Witch Project here. Okay, so we look at the top, the bottom, and the middle, and when we're looking for the bottom, what we're looking for is that change in color. We're looking for that little bit of change in color there at the bottom of the cylinder. That is what we're going to be looking for our bottom measurement. That's where that piston makes that turn and goes from going down to going back up. Okay, and that's where our wear is going to be. Anything below that is not going to be where the piston actually rides. It's not going to be where the rings ride. What we're looking for is where the rings ride in the cylinder. Okay, so we're looking to make a measurement here at the top, somewhere down in the middle, and then down here at the bottom just before it changes colors into that nice pretty metal that hasn't been touched yet. Okay, so 1, 2, and 3, and again we're going to do that 90 degrees as well. 1, 2, and 3. Okay, alright, so you should be able to see the measurements a little better. Okay, so I'm going to start on the side of the cylinder here. I'm going to go just below that ring where the top of the piston travels. I'm going to come up here, go to where it stops, and come back, and we're looking at about 3.5 thousandths. Okay, and remember when we're looking at this, okay, at the anvil when we push in, that's 4. If I push in tighter, meaning the hole is smaller, that's how this way to the right means how much smaller it is than 4. And then this way to the left means how much larger it is than 4. Okay, so when we're coming over here, it's not quite getting up to the 0. It's not making there, means, and it's on the on this side of the 0, which means it's larger. Okay, means it's larger. Again, if I were to push in and make the hole tighter, that would be a smaller off to the right, and then over here to the left, that is larger. So I'm looking at about 2.5 thousandths there. Okay, I'm going to push it down, go to about the center of the travel. Same thing, rock it back and forth, finding my top. We're looking at about a thousandth there, going down to the bottom again, right to the bottom of the piston travel, where you can, just before you can see the color change in the cylinder again. I'm going to rock it back and forth, and we've got about 1.5 thou. So we had 1.5 thou, we had 1 thou, and we had about 2.5 thou. Okay, so we're going to go ahead and we're going to write down all those measurements. Then what we're going to do, I'm going to move this over to the side a little bit. So I'm going to turn this, and I'm going to go recalibrate it, and I'm going to come back. All right, so I've turned it to the side so you can see the gauge, hopefully from in the video there. And yep, you can see the gauge. The 0 is about right here now, okay? And what we're gonna do is we're gonna go ahead and do the measurements the other way, the other 90 degrees. So here we go, I'm gonna put it just below that lip, and we're actually getting about 4 thousandths, right? So that'd be 4.004 there. Okay, we'll come down in the middle, and we're getting about, so we're going to go at the top here, just below the lip of the piston of the ring travel, and we're getting about 3 thousandths there. Okay, so that'd be 4.003 because it's off to the left-hand side, so it's wider. And then go to the middle, and we're getting about, well, we're getting about 2 there. You can get about 2 thousandths there. And then we're getting at the bottom, again, we're getting about 2 thousandths, okay? So I'll write down all these measurements, and then we'll go over them. All right, so we just took our measurements inside of our block looking for taper and out of round, and what we found is that we had about 4.003 inches because it's about 3 thousandths over at the top, 4.002 because it was 2 thousandths wider in the middle, and 2 thousandths wider at the bottom with 4.002 there as well. Off here to the side, when we made our 90-degree measurements, we had 4.0025 because it was 2.5 thousandths wider than 4.001, and 4.0015 because it was a thou and a thou and a half on the other side. And when we look at these measurements, when we compare 3 to 6 there, we're looking at a 0.0005, so about a half a thou difference there. Between measurements 2 and 5 here, we've got a 0.001, so we get about a thousandths there, and then again here about a 0.0005, okay, but half a thou, 5/10 thousandths. So overall, pretty even wear on these cylinders. This is a worn block. This is one that's been ran, okay? What would you expect after a piston's been going up and down inside a cylinder a bunch? Well, you'd expect to see a little bit of wear. You'd expect to see that hole get a little bit wider, and that's exactly what it's done. Okay, so real quick here, I'm going to talk to you about how to measure stroke. We don't have our actual deck bridge. I can't seem to find it, but it's going to look a little something like this. It's just going to be, it's going to sit on the outside of the cylinders. A lot of times it's magnetic at the bottom. You want to make sure you clean the deck off really good, clean the bottom of this real good so you don't get any discrepancies in there. And then what you're going to do is you're going to place it over the cylinder, and normally what it does is it has a dial indicator. This one doesn't reach to the piston, but it'll have a dial indicator that sits in there, okay? And so as you bring the piston up to top dead center, it's going to be moving, and then it'll stop, and then it'll go back down. And what you're looking for is that stopping point. When it comes up to and stops and then moves back down, you can move it back the other way. It goes up, stops, comes back down. You bring it up to that stopping point where it's not going to go any higher, and now you found true top dead center there for that piston. At that point in time, then what you would do is it would usually have another hole off here to the side. You would take something to measure the depth. You could either use a dial caliper or a digital caliper, and what you would do is you would stick it down and you would measure to the top of the piston, and you would get a certain measurement. In this instance, we're getting 2.5, okay? So that would be my base measurement. And then what you would do is you would take and you would turn it around to the bottom, okay? Turn it down to the bottom, and again, it has a special tool that goes down in there to where you could find bottom dead center, and you would just look for the very base to where the dial indicator doesn't move, and you'd look for the bottom, and then you would take your depth gauge, either a dial caliper, again, a vernier caliper. Another thing that you could use is a depth micrometer, okay? And a depth micrometer is meant to measure depth. So you would stick it, again, there would be a hole in the center of this, kind of like the one that this sits in, and you would measure from the top, and then your depth micrometer actually comes out. If we look up real close here, it comes out of here, and you can measure depth, and it's usually set to 0 for this for that flat edge there, okay? So if it was all the way in and flush, it would be at 0, and then we could go all the way down. So okay, it's an, you know, all right, it's an inch below that, and there's different adapters that you can put into there of different lengths that can get you down farther and farther. You could use a depth micrometer if you wanted to get super fancy with it and get exact with the measurements, okay? But we're not too worried about that today. Again, this isn't exact. So once we found bottom dead center, you know, we would set this up nice and flush, and then we would go down and we would see how far it is to touch the top of the piston. In this case, it is 5.5, okay? And it's actually almost dead on 5.55, and our original measurement was 2.55. So you take the difference, 5.55 minus 2.55, and the difference is 3. When you look up the stroke for this motor, it is 3 inches is the stroke. Again, the stroke being the difference between where the piston is at on bottom dead center versus top dead center, and how far that is. So I know this is kind of just a cheesy little demonstration. Once I find my bridge, I'll do a better demonstration of it, but that's basically how you're going to measure stroke.